Hi, I'm Andrew Armstrong and welcome to the Back Office Teardown Lab. So if you've seen this channel before, you're aware that I quite like these kits. Generally they come with Arduinos. However, this is the Elecrow Raspberry Pi Pico kit, which comes with the Raspberry Pi Pico, which is interesting for two reasons. One, it's a Raspberry Pi Pico, which means you're going to learn to use MicroPython as default, although you can put the Arduino stack if you want. But two, Raspberry Pi have released a Wi-Fi version of this, which will then extend your project. So if you use the equipment here to make a nice project with this, you can swap in the Wi-Fi one later and then get that Wi-Fi goodness added to your project. So looking here at the box, it says basically you've got your Raspberry Pi Pico and 32 different sensor modules, but what's really interesting, it's a car kit, so it has a chassis with motors, and it does say there's 32 MicroPython lessons, so that'd be very good for if you want to learn. Now, I don't tend to use these in a learning capacity. I like these kits because they offer me a grab bag of multiple different types of parts, so you can take out of these whatever you need, really. I think if you're going to want to learn about microcontrollers, these are obviously a great way to start because you get a little bit of everything. And here you have a nice chart showing a big description of all of the components that you'll find in this box. So let's have a look at the description of the components available in the kit. So first you get your Raspberry Pi Pico. You get two infrared tracking modules, and you can see they have adjustable sensitivity on them. An infrared receiver and transmitter, so they'll go together so you can use the remote control. 5 coloured LEDs, which is always fancy. An RGB LED, which is interesting, so that allows you to change the colour of the LED by varying the amount of power or PWM you're going to put down those wires there. Interesting. A push button, just a normal tack switch with a dome from the look of it. A sound sensor, which appears to be a microphone, but with probably a digital-ish output. So there's a adjustment pot there. So it probably just triggers. So once it receives a certain volume of sound or shape of sound, it'll then output a signal. A PIR sensor, very cool, so you can track people moving around. Let's see what else you got. You got a light sensor, which is just an LDR that's probably coming on analog input. A red laser transmitter. Ooh, now that is cool. A buzzer, and I don't know if that's a self-contained buzzer. So a self-contained buzzer, if you apply power, it just starts buzzing. And other kinds are really just speakers, so you need to actually PWM them. A vibration sensor, that'll be curious to see how that works. It looks like a spring in a tube. A reed switch and a magnet, so a magnetic switch and a magnet. A soil moisture sensor with cable, very interesting. Potentiometer, motor drive modules, that'll be your H bridge for those motors. It says motor ×1 plus a flabellum. Which I think is a fan blade, a flabellum. Never heard it called that before. A servo, and I don't know why you need a servo, but you got one. A joystick module like your Xbox, an RFID module, and RFID tags, which is super cool. They're always fun to have RFID tags. A 4-character LED screen, which is interesting for that retro look. Traffic lights module, rotary encoder. LCD module, so you can drive some actual text on the display. It looks like a humidity sensor right there. A raindrop sensor, a flame sensor. Interesting. So I guess that's maybe an infrared type of sensor there with some adjustment on it. An SSD 1306 OLED, always useful. That's the I2C variety because it's got 4 pins. A matrix keyboard, ultrasonic sensor, collision sensor, which are really just 2 micro switches. Took me time there. And a car chassis kit, which looks like it contains the motors, the battery, the plastics, everything else. And then, just going to zoom out, see the rest. You've got your USB, breadboards, DuPont lines, screws, nuts, bolts, and even looks like a screwdriver. So everything you need to do. And it does have assembly steps. Now I just have noticed something here as well. These motor things look like they have rotary encoders. So this is what it looks like in the box, though. You do just have a whole mess of stuff. Now it doesn't have the dividers that are typical in most of these kits, which is fine, to be honest with you. Look at that. I mean, if this was Christmas morning, you'd be really pleased to receive your flabellum here and motor. And interesting enough, this motor's red. Never seen that on the bottom of a motor before. So that, though, is the car chassis kit. So I think what I shall do is break out the components and really just assemble up the kit and see if there's anything on this Raspberry Pi Pico as by means of a sort of default program. Got my instructions propped up here, and I've taken out the chassis kit. What looks I've propped up the instructions and taken out the chassis kit, which appears to be totally self-contained within that box. It's just wrapped up in a bit of cling foil. But I do appreciate that, because it's a lot simpler than trying to pick out all these parts from that big old mess of parts in there. The assembly steps really seem to be referring just for this. So let's see what we've got. Now, we don't seem to have the H-bridge module or the breadboard in the box, so we won't have to pick those up later, but those will be far later in the build. Now, first things first, if you ever get these laser cut acrylic devices, just make sure you get rid of that paper, because you're never going to get it off later, I promise you. And even though they're a fingerprint magnet, if you've just got face facts, they're going to be covered in fingerprints anyway through use. So get your paper off. Yeah, it's not too bad. I've definitely dealt with far worse. It probably seems obvious, but it's just dawned on me while I'm taking these pieces out of the bag that you won't need a soldering iron for this. Everything here so far has been nicely prepared and trimmed. And I know, literally as I said that, this popped out, this power switch. I can see on the instructions they just wrap the wires around the terminals on it and the terminals on the motor. So I think there is opportunity for you to solder if you want to, but I think I'll be soldering there. But if you don't have a soldering iron, you probably can survive. I suspect though you will need a means of stripping the wire, which, let's face it, when we started out in this, we always used to just use household objects like scissors. But please, whatever you do, don't use your teeth. I can tell you from my own experience and several ruined teeth doing this, yeah, just never use your teeth in anything. Your teeth are not a good tool. The only thing your teeth should be chomping on is some, you know, poppets or some peanut M&Ms. So according to the instructions, they're not massively clear on this. It appears you have to fix your motor into the chassis in this orientation, so with the flat bit pointing backwards. I'm not sure entirely which way around the axles have to go. It probably doesn't matter, but I'm just going to go with the terminals pointing to the outside so they're easier to reach. And what you do is you slide one of these T-pieces through the back of the board like that. You grab your motor and then you drive 2 screws through there. He says not actually done it yet, but I'm pretty sure that's where you go. And probably just before you do that, of course, there is these rotary encoders, which is cool. I think you can probably put them in afterwards, but maybe just slide them on beforehand so that they're in the right position. And then put your outer T, and that should secure your motor pretty well. So I'm going to fish out the right screws and crack on. If you're doing this at home, I advise you put the top one in first, because the bottom one has a certain amount of adjustment, whereas the top one's the fixed one. So you know that's not going anywhere. It's quite a long screw, so at least that's nice and easy. You've got plenty of opportunity to pick up that thread. So I'm going to get it all aligned, and I'm putting pressure on that nut with this finger so I can just tighten up with this. And let's see if we need a nut spinner. Yeah, I think you can get it quite tight, but if you get little pliers on that, I'm sure you could nip it up a bit more. But don't do that just yet. Make sure you get that second long screw, machine screw through. Otherwise you won't have any compliance and you won't be able to move it around. So once you've got that second one done, which we're about to do now, then you can consider pliering it up. I'm going to do that myself just to show you. That's nice and tight actually, just from fingers, but if you want to, get your pliers or your little socket or your little spanner, whatever you've got, and then just give it a little twist, but not too much. It is plastic at the end of the day and you don't want to break anything. So this is a bit where we go slightly off-piste because the instructions call on fitting the H-bridge driver, which I'm going to pop there. So just in case you don't know, an H-bridge driver is a device that basically allows power to go to, let's say, a device like a motor. So you've got your left and right, your positive and negative. So positive and negative. And what an H-bridge does, when you normally connect that to a motor, it drives the motor in one direction. An H-bridge allows you to turn that round like that, so you can drive the motor in other directions. So you've got positive and negative, or negative and positive, and it can do that, and obviously off. So that's what this does. And in this board, it's saying you have to mount it like that, which I kind of think maybe we need a few nuts, or you're just going to jam it on. Not entirely sure, but you have to wire it up first before you do that. And what I'm going to do, rather than twist the wires, I actually am going to solder them because I don't want to have to do this again. So I'm just going to prop it up like so, get a positive wire and a negative. And again, you're able to swap these wires around later. You don't have to worry too much. Now, I'm not going to bother with poking stuff into the holes on the terminals, so I'm just going to put a blob of solder on each terminal. Now, it does look like these wires are pre-tinned, which is good. And I'm just literally going to dab them on like that. So that's soldered. Next one. And then just dab that on. Nice and simple. The wires are added, so let's get the screw terminals set up. So in the diagram they're going black, red, black, red, so we'll just follow the same. And remember, if it doesn't go the direction you expect, you can just swap these around later. So far so good with the tools that came with it, and I don't know if I showed you this, but look, bang, flathead as well. Oops, that wasn't very good. The next stage, they actually recommend putting these DuPont connectors on. Weirdly enough, of course, they have, starting with orange, yellow, green, blue, purple and grey. And if you look through your series of ribbon here, you can find those. So there's your orange, yellow, green, blue, purple and grey. But then you also have a white and a black, which you don't need, so I kind of feel bad doing it, but you're going to just strip these, and you need to keep it from the orange, orange, which is that lot, so take them off like that on the floor, and then we'll take off the black and the white, which we're probably going to use elsewhere. And we're just going to slip those on the old terminals. If I line them up nicely, like that, should be able to pop them on in one swift movement. Oh, so close. All but one. Bang. There you go. That's lovely. Lovely. I'm trying to figure out from their diagram, they're showing it this way round, and they actually have it connected like so. And I think they're just pushing it on the end of those bolts that are sticking through. It doesn't look like it's going to need any nuts, to be honest, because it seems to be a really tight fit. In fact, I'm to the point where I'm worried about poking myself in the finger with some sharp pin on the PCB. But that looks like as permanent a connection as you're going to need. That means now we can move on and fit what they're calling the universal wheel. I've got my 4 standoffs fitted. Now we're just going to pop this in. It's quite a nice little wheel, really. I think this would beautifully adorn any cabinet. There's quite a lot of play there. I'm surprised they don't have washers, but then it's not going to be particularly high stress situation, this wheel. Adequate. I think that grip will be adequate unless you're trying to move many tons. That was nice and easy. It's a good kit. And will you look at that, just like Jurassic Park? No expense spared. You've got proper bearing race. We can put some high performance lithium grease on that later. Just the battery box now, and there's plenty of scope on the battery box for sliding it around. I don't know why there is. Maybe they designed it so that you could fit all manner of battery boxes. Now, I do have a battery box that I bought somewhere, which actually has a lid on it. It's a totally enclosed battery box, and it has the power switch integrated. So if I had that lying around, I probably would have swapped that in. I am scouring the back office desk with my eyes whilst I'm trying to locate this nut to see if it is around here. But I suspect, like most things, it's gone AWOL. So I think that's okay. We'll position that up right at the end. And then we have our power switch. So this is where we've got to figure out what goes where. See, one of these wires will go straight to the Raspberry Pi Pico. Not sure if it's the positive or the negative. Again, we'll work that out. And then we have our power switch. But it looks to me like the wires out of this thing actually will go through one of these holes, like so, and then connect to the switch underneath. So we'll figure that out. I'm just going to solder this red wire right here. I'm not even going to shorten it. Get in there. Here we go. And then we'll just attach another wire to that other terminal that will go to your board. And it looks like your board and everything's going to mount on top here, and everything comes up through this hole here at the front. Right, breadboard time. Solderless breadboard. And these always come with this really handy dandy lump of adhesive on the back. And I'm going to mount it the same way that they show in their diagrams. So I'm guessing somewhere like that. They've got it butted up, and they've got this red positive on the outer one this direction. So let's just, I guess, just shove it in and hope it's in the right place, because that is a large surface area of adhesive to have to come and try to pull this off later. And see, it's already starting. I'm hoping it doesn't interfere with those encoder wheels, but I think we're okay. Just going to push that on like that. Give it a good old squeeze from underneath now. There are a lot of holes cut in here. I'm hoping we don't need to get to them, because we're certainly going to have trouble now. And we do have the Raspberry Pi Pico, and what's great about this, it actually has all the headers soldered on it, so you don't have to have it soldered on. And I believe if you buy them from the usual places like Pimaroni and all of those, that you can order them with these headers on or off. So if you're going to use it for breadboard, yeah, get them with the headers. If it's for your own projects, you've got a soldering iron, don't worry about it. And you do have these 3 bits of pin header in the bag that came with it for this debug header. And I have to admit, I've never really used it at all. So if you've used it, please comment down below. I don't really know what it does. I'm guessing it's some sort of serial, but I don't know if it's a digital serial or not. And interestingly, on their diagram, they're showing it mounted like this, which to me totally sucks, because how do you get to the USB? I would have had it the other way around, but oh gosh, I think I might have to just now look, for me, I'm going to go off piste, because I think I would rather have it the other way around. Because looking at their diagram, they've got it with the USB inboard, and you can see they've got the wires coming from the front going all the way over the board to the other side to some I/O, and likewise they've got all the power rails coming from here to there. So let's see, I'm going to crack on with it and let's see if I regret it, shall I? So I'm going to pop it this way. I bet every diagram, if you go online and you find the instructions, you know, like the implication was you had a course or something to follow online, it will show it in the orientation that they've got it. And I am just setting myself up for future heartache. But to be honest with you, the old Raspberry Pi Pico is so simple, and the GPIO is so easy to understand. I don't think you will have a problem. It's better, if anything, that you learn how to use it. there we go, without following pictures rote. You know, you've got to figure out what you're doing. So let's have a look here and I'll see if I can figure out what they're doing. So they are connecting these up to the power rails, so that's absolutely fine, and we can keep that the same for simplicity's sake. So the green is our switched live, and I'm going to put that onto the positive there, so when we switch that, power will come into this green line. And then the black is also a bus, and it's a bit thin. You might want to, in fact I'll show you what I'm going to do, strip it down a little bit more. I'm going to give an extra couple of mil to make it that little bit longer, and then I'm going to take my soldering iron and I'm just going to put a lot of solder on it. So I'm going to give it old heavy tinning, so I want to thicken it up basically, because they have to poke through that breadboard hole and be quite rigid, and then bite in, well, allow the actual copper contacts in there to bite into it a little bit, and that feels a little bit stronger. Of course you can always put some tape on them when you're done. So let's look at their diagram here as well now, and you can see they're attaching the purple, grey, in fact, I'll have to decode it in my brain, but as far as I can tell, the green and the blue are power. So the green and the blue are going to be connected to the power rails, which we will split and do that. So, and it looks like the green is going to the positive and blue to the negative, so we can do that no problem. Like so. And depending on how you want to use your breadboard, you can put them a little bit more inboard to give you more room to this working area. So I'm going to strip these back now. And then it looks like so we've got these GPIO ports here. Again, I'm not entirely sure on the pinout. Some of these boards, by the way, have a nomenclature written on the side. Certainly the Arduino ones. So when you plug them in, you can actually read off what the actual pins do, but we're just going to shove them in. It looks like they've got them set for a particular GPIO, so I'm just going to follow the same colour. Assuming it starts at the end, you're looking at something like that, and then orange and yellow. So purple, grey, orange and yellow. It's all a little bit jury-rigged. I mean, it's one step up from just bits of loose wire and free form, but you can see that looks actually quite good, doesn't it? I think that's a little bit better orientation. Certainly make it easier to plug the USB in. Or will it? Have I just shot myself in the foot because I haven't put the bloody wheels on yet? Yeah, good luck getting a USB connector on that with a wheel on. Okay, so having referred to the pinout to confirm my guess, the picture's not too clear. I will show you how I've hooked it up, which may or may not be right, but I'm hoping it is. Focus you. So I've hooked this up as best as I think. The third pin along here is ground, and these are two V-bus, so that makes sense from here. And on this side, on the Raspberry Pi Pico, you have two GPIO lines and a ground, so we don't really want anything onto the ground, so we're just going 3 dots, 3 spaces, and then we're connecting these 4 in a row like that. So I think we're pretty much there. I did check, we can get the USB in here okay, so we are able to mount the batteries, which we're going to do now. And I did say batteries, I meant wheels. We're going to mount the wheels before the batteries. I'm not sure about these screws. They may or may not be for this. I mean, they certainly look a lot bigger than the holes allocated, but I'm going to have a go. If not, I'll have a look in the old screw box, because I think you definitely want something on these, because these will just flop off. Those almost certainly are not the actual screws you need. The screws you would need would be so long that I don't even have any that would actually be long enough to work. So what I'm doing, I'm bending over a bit of an old component lead. Have a look there. Just the leg of an old resistor, you know, the offcut through a through-hole part, and just using that as a raw plug, just pushing that on. And that's giving it plenty of bite, so it's definitely not going to come off. Just like that, and you can see they ain't going nowhere. And that, it seems, is where the instructions end, because beyond that, basically we've got a map, which I suspect is for that infrared sensor, which is not covered in this, so we probably have to go online. I am curious though as to what will happen if we put some power on, so I think we should just try that. Batteries are in, power on. Nothing. Although I do see an LED on our H bridges on. I wonder if we can just fool it. We have a little bit of an experiment here. So if we take power from the power rail and we just twiddle our H bridge output, see if anything happens. No. We probably have to flip them. Anywho, I think it's time to plug this into a computer and actually have a look on the internet, see what we do next. Elecrow, Pi Pico. Unfortunately for me, my internet seems to be down. We've literally just had the BT OpenReach engineer leave saying there's no problem and it's all working fine, and it's dead. So I have this hooked up to my mobile phone hotspot. So we are... Oh! Yeah, I probably ought to just turn off YouTube. But yeah, I've got it hooked up on my mobile phone to their website just to see where the link is to these lessons. But just to show you some interesting things, at the moment it's about $36 plus an extra $5 if you want the actual Pi Pico included in your kit. But what was interesting here, it does actually have the pinouts quite nicely on their website, but a few projects that they suggest you can try. So you have the RGB colourful light, you have an electronic clock, colourful flowing light. I've always wanted a flowing light. A billboard which says "Hello Pico," a plant doctor. So if you need doctoring your plants, you've got a plant doctor right there, and an alarm of fire. And it's got a message on the screen here that says, "Warning, be on fire!" Yeah, so be careful about being on fire. And then of course you have the car project. And I didn't notice that there isn't actually an ultrasonic module that comes with that, which is pretty cute. That's very nice. And then the traffic light kit. So there is the only link I could find on their website to something that's slightly tutorial-ish for this is the Piper Make. And I've never seen Piper Make before, and it does look really cool. It's got story mode and creative mode here. And it appears to be got sort of Minecraft graphics. You see, set up my Pico. So I am going to try to hook stuff up with this Piper Make while I've got my internet down. And maybe that's what we need to progress in this project. And I know some of you are probably thinking, why don't you just fire up Thonny? That's what you were using in your previous video. And it's like, yes, I can fire up Thonny. But I suspect we're going to have to go through official channels if we're going to try get hold of their tutorials, and this is all I've got to go on. Now I have plugged the USB in, and right away I could see power on the H-bridge module, so that bypasses the battery and the power switch. Just be aware of that, you're now powered up. And of course I do have the Raspberry Pi 2 file-based bootloader, but I am going to use this Piper Make. Again, never tried Piper Make. Don't really know what it is, apart from, turn my lights off, apart from maybe it's just some sort of kids learning thing. So it says, get started, start mission, set up my Pico. So I'm going to hit set my Pico. Do you have a new Pico, or does your Pico need to be updated? Yes. Please make sure it's unplugged from your computer. All right, I can do that. Next. Now, hold down the boot select button, and that's the big button on the Pi Pico, it's the only button, and then power it in. So that puts it into the recovery bootloader mode, like so. Then click next. Oh, where did it go? Let's try that again. Next, next, next. Yes. Choose the RP. Okay, so I'm going to choose the folder of the Raspberry Pi 2 and then click select folder and then click view files. So that lets save changes. That lets this web page effectively access your hardware, which is quite cool. So it's going to load the file straight from the internet down the wire into that. So that's quite convenient, really. You don't have to do anything. And it says here, add Circuit Pi. So now this is called Circuit Pi. Great. So I'm going to click Start Mission. And then there's a video to watch, which is exactly what you want when your internet is hooked over your mobile phone network. Basically, I blitzed through the whole tutorial. I say blitzed through it, I actually closed it. I didn't look at it. Because I could tell, this is effectively like a Scratch type interface. So if you've used MIT Scratch, and you will have seen in a video, literally a few weeks ago, I did a video on this subject, that you have these graphical building blocks that you can pull in. You just literally connect to your board using this connect button that now says disconnect. And you just start putting your building blocks. And then at the bottom you do have this handy digital view that shows you what's going on with the pins, tells you the pins and actually shows you them flicking on and off. You have a console, the usual graphics type console. You have a data view here, and I haven't seen what happens on this, but I suspect it actually updates and shows you graphs and things. And then you have a Python view, because as you put in those building blocks, it's actually building micro Python code. So it is a little bit nicer than Thonny. If you remember previous videos, we were using Thonny, which was a bit like the Arduino equivalent for this, but this is something a bit more kid friendly, and I'm actually very excited for this because I'm definitely going to let my kids just play with this. And there's actually these really interesting looking things here when you go through all these tutorials that show you all the things that are available, pretty much cover what I mentioned and how it all works. And I already have actually put together a little program, which I think maybe I can zoom in. Yes, you can see. Now, if you remember, we actually attached the motors on pins 10, 11, 12, 13. So they're listed here along the bottom, 10, 11, 12, 13. And you can see what we basically said. When we start, turn pin 13 on and then turn pin 12 off. So that will activate the H-bridge in a particular way. In fact, I'm going to hold this car like that so we can prop it up against some random stuff. So when I hit start, we'll have a look at this. And you can see it turned for a bit clockwise. There's no loop here, so it's just running through once basically. And you can, if you look down here, you can actually see it shows you the colours of that on that digital view. So what we can do is actually flip them round, and let's say pin 13 is off and pin 12 is on, and if we're lucky it will come round anti-clockwise. And there you go, and that's how you start formulating your thing to make your car. So what you need to do now, though, of course, is then to add all of the other building blocks and logic to hook up your car. And then just, if you go through your box of tricks, so you've got your big box of tricks, this is where everything comes into play. I mean, obviously, follow your tutorials, go through everything, learn how it all works. But once you start going through your box of tricks, and I'm just going to grab some out. Let's say, for example, we want to hook this lot up. And I'm going to shut this so we can cover that and just show you how it works. It's nice and simple, so you don't really need too much in the way of tutorials to figure out what's going on. So here, for example, is the infrared sensor, and you could see in the example that they had on the box that it's following a line on the paper there, and this is pointing straight down. You've got a transmitter and a receiver like that, and then you've got an adjustment that will adjust its ability really to switch on between 0 and 1 based on seeing black or white. So you want to adjust that based on all the ambient light conditions and things like that. Normally these things being quite close to the paper is the best, and then you would tune it up while it's quite close. And then the thing here, which would be quite common on lots of things you'll see, you have GND and VCC, so that's ground and voltage. Yeah, so your black wire always goes to ground, your red wire will go to VCC, and on your device here you could see you have these power rails. That's why these are doing that. So you could actually plop that somewhere on even a bit of breadboard or one of those DuPont connectors like this. Okay, so you would put a black wire, say, on the ground, and then you would put a red wire on that VCC like that, and then you would put whatever remaining colour you've got, brown here. And then really, oh, I don't like doing it, but let's just strip it off. If you did want that to work, we would just put the black and the red on those power rails that you've got here. So red to positive, black to negative, which we will do. And then we hook up this remaining wire onto one of those inputs. And I think we should just do it while we're here. You know, this is a live example. And the idea is as you go along and you build your logic for your vehicle, you'll be able to start adding those sensors. And so I would start really with just getting it moving forwards and backwards, and beyond that you could then start getting to do other tricky fun things. So if I'm looking here on the bottom, I can see these GPIOs. I'm going to hit connect, by the way, because we want to connect to that device. And I look at the GPIOs, and we've got pin 9 here is available. You can see just there with my fingertip, pin 9 is available. So let's go for that. So I'm just going to now hook that wire, see if I can locate pin 9. So we had those 4 motor wires there, and then we had one gap, and then we have pin 9, which now we are connected, like so. And interestingly enough, I wonder if we dynamically change this, if we'll see anything on here. So I'm going to play with this device, and you can see there's the LED coming on and off. So that's detecting that infrared signal. I'm not seeing anything right now. I think we have to be started and running. So let's now remove the blocks here that affect the motor. Just got rid of them totally. And let's have a look here to see if we can see the inputs. So read voltage, look, here we go. There's a read voltage from pin. How do we put that in there? So you can see now I have finished my program. It says start and repeat forever, and it says if pin 9 is low, then play sound drum kit. And then I have over here so you can see my program here. It says start, repeat forever. If pin 9 is high, then play the drum kit clap 1 sound. And then it will wait half a second and rinse and repeat. So I do have the thing hooked up here, and I have the wire with the sensor, and you can see when I put my finger over there, we get a kind of a pretty lame clap sound, but it is a clap sound nonetheless. And there you go, we've actually hooked up our first sensor. So without any instructions, I think I'm just going to crack on and figure out what I can make with some of these pieces. And there is our ultrasonics. There is our light sensing. I think we want our basic car type stuff. I've hooked up those sensors, the infrared sensors that should bounce off a piece of paper. I'm currently covering them with my finger because I don't want them to go off right now because they're a bit noisy till I get to explain what I've done. I am sensing them, and I just have some logic. So I basically say if both of them are high, then set the direction to 1. If one of them is high and one of them is low, you set that direction to 2. If one of them is low, the other one is high. Vice versa, you set that to 3 and 4. So you've got like a few directions. And then I've basically set it that when it's receiving that, which is probably the reverse logic it actually has to be, by the way, to follow the paper, but it just gives you an idea. Once they're both exposed, you can see the wheels are moving in the same direction. So when they're both experiencing the same thing, the wheels move in one direction. And then if one is covered, you can see the wheels are moving in opposite directions that way. And then if I cover the other side, they go the other way around. And then both together, it's off. So I'm going to have to do a bit of tuning with that black and white piece of paper just to make sure that they're the right way around. But the idea is, whilst they're both or either of them are on the black line, this should continue to drive to try to follow that map. However, when it goes off the edge of the map, so when it hits the white, it should just stop because I don't want it to run away. Come on, come on. It's kind of trying, look. Come on, let's try again. Ready? Look at that. It is kind of doing it. Needs some fine tuning. Now, I will admit, I have gone into Thonny. It was far too painful using the other IDE, but it's interesting. What was really cool is actually I cut and paste from the Python in the other UI, and when I hooked this device up to Thonny, it recognized it as a circuit Python device, and I pasted the code and it just ran straight in. So I am just going to try to tweak this a little bit because I feel like it needs a little bit more momentum on a turn. Okay, my laptop has died and I'm just far too lazy to go plug it in. However, I will show you this. It is kind of working, and the issue I have, for example, with this fine tuning is when it's turning, I need to give it a little bit more of a delay than when it's just going straight ahead. I'm changing the cycle time of the loop because I want it to pay a little bit more attention to the sensors on certain things. Now I'm trying to tune that in using the laptop and the USB cable, loading Thonny and changing the value, and then I have to unplug it all because at the end of the day this is a car. And this is the perfect opportunity, you see, where you've got a Wi-Fi option, because you'll be able to save those parameters as variables and be able to adjust them over Wi-Fi, because this is definitely not the way to do it. And I don't really know how else to do it apart from maybe adding some of those encoders. If you remember in the kit, it did have a knob, and you could basically wire up a couple of potentiometers or a knob or something, and then as you turn them you can adjust those settings and tune them in and then read off that value later for your program. But I will show you what it is doing now. It's kind of working, right? So you can see that nodding. That's because it has too much time to move, so it should probably be a bit shorter on that. See? And then there is another variable on this, of course, which is the sensitivity of these. So you've got quite a lot to play with, really. Yeah, I've broken it now. But just to show you, even with my finger over the end, I've noticed that they're not quite the same. So as you tinker with them, you can see that they don't necessarily all cut in and out at the same time. Anywho, oh, I think that was pretty good. I'm more or less happy with that. That's what I wanted it to do. In conclusion, I think that this Elecrow Raspberry Pi Pico kit is really good. I actually think for the money it's a very good value kit. You're getting a lot of components here. Clearly I haven't opened them. They're very similar to the other kits you get for Arduino and things like that, so that lots of things haven't changed. But as a primer to learn how to control it, you could see though relatively quickly I could load up the basic scratch type interface and get stuff going. If I hooked up sensors to these GPIOs, I could read them and see the values and obviously affect output, in this case by twiddling the motor. And then loading up Thonny give me that fine grain of Raspberry Pi, sorry, I say Raspberry Pi, Python, circuit Python code that lets you just go in that little bit deeper and start twiddling things exactly as you want. And of course, if you're more Arduino based, you can load the Arduino IDE, and that's kind of cute as well. I'm not quite so familiar with the circuit Python, but the Arduino will have drivers for a lot of these that you can just bring in, and it will automatically be able to interface those. Again, you have to program in C, but I know a lot of you out there do already program in C. So I think that's it for today. I'm going to go play on some Xbox, a bit of Minecraft, but yeah, it's pretty darn good. So yeah, if you're that way inclined, go away, buy one, and leave a comment down below how you get on. Come chat to me on my Discord, and as ever, thank you for watching.